Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be starting Section 2 of Chapter 2, Point-Slope Form. So the point-slope form of an equation says y minus y1 equals m times x minus x1. This form of an equation is a little bit longer because it has something called a point and a slope in it. The slope is identified as what is m, which would be the number in between the equals and the first parentheses. That's still the slope of the line, which is rise over run. However, the point-slope form will also give us a point on the line. That point comes from the two values x1 and y1. And when we write it, we have to remember to write x first and y second because that's the standard way to write an ordered pair. So using this definition, we're going to practice identifying slopes, points, writing the equation in slope-intercept form, and graphing a line from this form. So let's get started. Our first example says to identify the slope and one point on the line y minus 3 equals 1/3 times x minus 6. So if we recall, the point-slope form of an equation is y minus y1 equals m times x minus x1. So when I write the slope and point from the line, the slope is going to be the number that is after the equals but in front of the parentheses. In this case, if I match up my two equations, the slope would be 1/3. So I would say the slope of this line is 1/3. Now the point comes from the x value and the y value. So when I write the point of this line, I have to write down what x is and what y is. Now conveniently, the x value comes from what follows x and the y value comes from what follows y. So if we take a look, what follows x first is a 6. Now you might think that it should be a -6, however the original equation already had minuses in them. So when we write the point, we actually write the opposite sign of what we see. So my x value for this one would be 6. Now for the y value would be what follows y. Again, for the points, we're going to write the opposite sign of what we see, because there was already a subtraction in the original equation. So while it looks like a -3, it's actually a +3. So when I write the point, it's going to be the point 6, 3. Our second example says write y minus 3 equals 1/3 times x minus 6 in slope-intercept form. So for this problem, what we're going to do, we're going to take the point-slope form and we're going to write it as y equals mx plus b, because if you recall, that is the formula for slope-intercept form. So to get this in this form, we essentially need to solve the equation given for y. So we're going to draw a line down the equals, and I always start on the right-hand side by distributing the fraction first. So 1/3 times x is 1/3 x. And then 1/3 times -6. Well, in order to multiply a fraction with a whole number, I need the whole number over 1. And then I multiply straight across. 1 times -6 is -6. 3 times 1 is 3. Once I multiply the fraction and whole number, I then want to simplify if possible. In this case, I know that 6 over 3 is the same thing as 2. So I have 1/3 x minus 2 on the right-hand side. I will now drop down the left-hand side, y minus 3. And what I want to do, I want to get the y by itself. So to get rid of -3, we need to add 3 to both sides. When I add 3 to both sides, I'm going to be left with y equals I have 1/3 x, and negative 2 plus 3 is positive 1. So I now have it in the form y equals mx plus b. This easily tells me the slope is 1/3 and the y-intercept is at 1 because that's what slope-intercept form is used for. Our third example, we're going to take the equation we have been working with, y minus 3 equals 1/3 times x minus 6, and we're going to graph it. So in our first example, we found that the slope was 1/3 and that there was a point at 6, 3. In the second example, we found that the slope-intercept form was y equals 1/3 x plus 1. So when I graph this, what I'm going to do is I'm going to use my y-intercept, and I'm going to start by plotting my points at that value. So on the y-axis, I'm going to put a point at 1. And then from that point, I'm going to count my slope, which is 1/3. So I need to rise 1 and run 3 and put a point in that general location. And then I need to count that one more time. So rise 1, run 3, and plot a point. Once you've plotted your 3 points, connect them with a line. Make it as straight as you can. That was a little curvy. And then put arrows at the end. Now what you should notice, we just used the y-intercept and the slope. But what we should notice is that our point should also fall somewhere on that line. So if we look, if we go over 6 and up 3, right there is our point, which did in fact fall on that line. So everything is connected. The y-intercept and the slope and the point will all help you graph this equation. Our next example, we want to identify the slope and one point on the line, y plus 2 equals 1/2 times x minus 4. So remember the point slope form, y minus y1 equals m times x minus x1. So when we identify the slope of the line, slope is represented by m. If we match up our equations, m is what's after the equals but in front of the parentheses. In this case, that would be 1/2. So our slope of the line is 1/2. As for the point comes from your x value and your y value. And when we write the point, we're going to write the opposite signs of what we see. So when you write a point, x comes first. We're going to look at what's next to the x value. And while it looks like a -4, points are backwards, we're going to write +4. Then figure out your y value. Next to the y is a +2, but since we write the reverse, it's actually at -2. So your point would be 4, -2. We now want to take that equation and write it in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So I need to solve my equation in point-slope form for y. So I'm going to start first is drawing a line down my equals. And on the right-hand side, I wanted to distribute the half. So 1/2 times x would be 1/2 x. And then 1/2 times -4. I'm going to put the 4 over 1 and then multiply straight across. 1 times 4, 2 times 1. Then I want to simplify because I know that 4 divided by 2 is 2. So on the right hand side, by distributing the 1/2, I get 1/2 x minus 2. On the right hand side, I still have y plus 2. So since slope-intercept form has y all by itself, I need to get rid of the plus 2 by subtracting 2 on both sides. This will leave me with y equals, drop down the part with x, 1/2 x, and negative 2 minus 2 is negative 4. So just by looking at my equation in slope-intercept form, I can see that the slope is a half and that the y-intercept is at negative 4. So now I want to graph this equation we've been working with. Y plus 2 equals 1/2 times x minus 4. So what we want to do is recall that in the first part we said the slope was a half and there was a point at 4, negative 2. And in the part right before this, we found that the slope-intercept form was y equals 1/2 x minus 4. So when we graph, what we're going to do is stick with our original system. We're going to start by plotting the y-intercept, which would be the number being added or subtracted to mx. So in this case, that's negative 4. So on the y-axis at negative 4, we're going to put a point, and then we're going to count our slope, rise over run. We're going to rise 1, run 2. Rise 1, run 2. Once you have them, you're going to connect your points as best as you can. Again, hopefully yours are straighter than these. And then the last thing we're going to check, because we already used the slope and the intercept, we're just going to make sure the point 4, negative 2 was in fact on this line. So if I look at 4, negative 2, I see right around there I do in fact have my point where it should be. My graph's a little bumpier, but I see there's a point around 4, negative 2. So again, everything is connected. The point, the slope, and the y-intercept will all be on your graph. Our last equation, we're going to identify the slope in one point on the line, y equals negative 1/6 x plus 3. So our slope of the line, again, is always the number after the equals, but in front of the first parentheses. In this case, that would be negative 1/6. And our point comes from figuring out your x and your y value. So your x value, we look to see what's with x, but we always use the opposite sign of what it looks like. So this looks like a positive 3, which means we're actually at negative 3. And then after the y, there's no number. So you have to think what number means nothing, and that would be 0. So we have a slope of negative 1/6 and a point at negative 3, 0. So now what we're going to do is take that equation and write it in slope-intercept form. So I always start by distributing on the right-hand side first. So negative 1/6 times x, and then negative 1/6 times 3. So I have to make 3 a fraction by putting it over 1, and then multiply straight across. 1 times 3, 6 times 1. Then I want to simplify if possible. Well, I know negative 1/6 x doesn't simplify, but negative 3 and 6 can both be divided by 3. So I'm going to simplify this to minus a half. Now that I've simplified, I'm going to drop down the y. And I have it in slope-intercept form. Y equals mx plus b. So this tells me my slope is negative 1/6 and my y-intercept is negative 1/2. So we are set to graph. So we're going to graph y equals negative 1/6 times x plus 3. So if we recall, we first said the slope was negative 1/6. We identified there is a point at negative 3, 0. And we found there is a y-intercept at negative 1/2 once we put this in slope-intercept form. Now, Starting by graphing at -1/2 is not a good idea because graphing at a decimal is hard because you have to guesstimate where it would go on the graph. So what we're going to do, we're going to use the point and the slope to make our graph of this line. So we're going to start by plotting a point at -3, 0. And then from there, we're going to count a rise of -1 and a run of +6. So down 1, right 6. And then count that one more time. Down 1, right 6. And put your point. So once you've got your points, we're going to connect them in a line. We're going to draw arrows on the end because the line keeps going. And then we're going to relate the y-intercept back to our graph. This says the y-intercept should have fell at -1/2. So that would be in between 0 and -1. Well, if we take a look at my line, it's around that area. So we know we graphed the line correctly. So again, everything relates. Your line should always have the point and the y-intercept with the correct slantedness from the slope. This concludes our lesson on being able to use point-slope form and create a graph and convert to slope-intercept form. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.